Let us understand why this formula exists. Let us first roll to the Cartesian plane of set x and their y axis respectively. If we take a vector r1 here, this is r1 vector, and this is the r2 vector, and this is the r3 vector, then we know that these three vectors can be represented in this form. But why? So to understand why we can represent these three vectors as a combination of this equation, let us think of this as the parallelogram law of vectorization. If we connect this, if we make a parallel line from here to here and from here to here, then we can see that this R2 vector is the vector sum of R1 vectors and R3 vectors. And we know that before starting, you guys understand what these scalars A and B does to our vector. So let's consider we have a vector that is named R1 vector. And if this scalar is 2 here, then what this does is it doubles the magnitude of our R1 vector. So technically it will be this length. If this was minus R1 vector minus 1 R1 vector, then it will reflect the direction of our vector. Since initially our vector was going in forward direction, now vector will be going in backward direction with equal magnitude. We can just add the scalars here, A R1 vector and B R3 vector, as it does nothing more than scaling up our vectors or changing the direction of our vectors. This will not break the parallelogram produced by these vectors.